Yeah, I guess. All right, we're trying this. We're going to see how this goes. Let's try to zoom in a little bit. Okay. Let's see. All right. Hey, look, there's me on that screen. All right. So like I said, gentlemen, thank you. So like I said, today a lot less doing, a lot more thinking. So we're talking about rational and irrational numbers. So we've already been talking about rational numbers a lot. Like the entire first 2 units were literally adding and subtracting rational numbers. That was unit 1. And then unit 2 was multiplying and dividing rational numbers.
We do a lot of rational.
Yes, we do. Rational numbers are the ones that make the math easy. And it's the ones that you guys use on a regular basis, okay? It's all of these. Anything that can be written as a fraction, like that is important. Anything that can be written as a fraction is a rational number. Whoops. There we go. So when we're thinking about anything that can be written as a fraction, whole numbers. How do you write a whole number as a fraction? What do you do? Say it again, Sandra. Yeah, just that a whole number is a number over 1. Okay? Integers. How do you write an integer as a fraction? Ladies and gentlemen, how do you write an integer as a fraction?
You convert it into like
You're thinking too hard. How do you put an integer as a fraction?
Put it over 1.
Yeah, just put it over 1. Okay? How do you write a terminating decimal as a fraction? Well, give me an example of a terminating decimal. 0.33 is not a terminating decimal. 3.2 is a terminating decimal. Let's go with 3.5. How would we write that as a How would you write that as a fraction? 3.5 would be 3.5. Or you'd say this as 3 and what? 5/10. Exactly. So you just say it out loud. Repeating decimals. 0.33. Exactly. 0.3 repeating. Or 0.45 repeating, right? How would we write those as fractions? Well, those are a little bit harder to write as fractions. Those are some of those we just have to know. Some of those we can just know what the fraction version is. And then we also, our new one, so we've been dealing with these. We've dealt with those. Our new one that we've added in since yesterday is our perfect squares. Or specifically square roots of perfect squares. If I take the square root of 25, what's it going to equal? 5. Is this a rational number? Why?
Because it could have done it ended in 0.33.
Nope. So what can I do with this? Exactly. So is this a rational number? Is this a rational number? Yes. Absolutely, because I can simplify it and write it over 1. So that's irrational. So now, irrational numbers, irrational would be not rational, right? There's two options, right? Non-terminating, non-repeating decimals. So terminating decimals are those that end. So non-terminating are those that what?
Never end.
That never end. Repeating decimals are those that repeat. Non-repeating decimals are those that don't repeat. So these are decimals that don't repeat and don't end. Okay? You guys all know pi. That is one irrational number. There are infinitely number of irrational numbers. In fact, there are way more irrational numbers than there are rational numbers. Think about it. There's a ton of irrational numbers. There's only a smaller number of rationals. We've just added in, the new one is a square root of any non-perfect square. Now we saw those yesterday, right? We saw some of those yesterday. We estimated some of those. That was that 14 through 17 on our homework.
Yeah.
So this is an example, square root of 40. Well, square root of 40 is in between the square root of 36 and the square root of 49, right? So we know it's going to be in between 6 and 7. It's closer to 36 than it is to 49. So like 6.2, 6.3. Turns out when you plug that into the calculator, you get this. And it keeps on going forever, and it doesn't repeat. So any square root of a non-perfect square will be an irrational number, any of them, okay? So here's another way to think about this list, right? So you have this image on your notes. Like I said, today's notes are more thinking notes than they are doing notes, right? So we have to think through this. This is kind of understanding a set of numbers. That's what this is. Okay? So we've got this table here. These are called real numbers.
Real?
Yep. That's because there's a set of numbers called the imaginary set of numbers. We aren't going to deal with those until Algebra 2, but just know that everything that we've been working with are all real numbers because we can represent them in the real world. Okay. So that's every single number that are here. All numbers that we are working with are real. All of them. Okay. Now, we've been dealing with rational numbers most of the time, right? So you kind of think of whole numbers are specific kinds of integers. Integers are specific kind of rational numbers, right? So some rational numbers, 3.7878 is like a repeating decimal, or a mixed number. Those are rational numbers. Integers are whole numbers that are both positive and negative, so negative 112 and negative 8. Whole numbers are only positive, right? 2, what's the square root of 9? 3, so that would be a whole number. Now, we're also introducing irrational numbers. So pi is one of our irrational numbers, because we know that it goes on forever, doesn't ever repeat. The square root of 30, that's a, let's do this. There we go. Square root of 30, we have is irrational because it's a square root of a non-perfect square. What would this be pretty close to? Square root of 30.
Pretty, 5.
It's in between 5 and 6. Is it closer to 5 or is it closer to 6?
5.
Yeah, just a little bit closer to 5 though, right? So what would we think?
Like 5.3.
Probably 5.4, 5.3, yeah. 5.4, 5.3. And then this one, why is this an irrational number? What do the dot dot dots imply? That it keeps on going. Now, the only way that this will be irrational is if it doesn't repeat after it gets to 9. Because what if it went to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. What kind of decimal would that be? Look at your list. What would that be? That would be a repeating decimal. And what do we know about repeating decimals? Look at your list. Repeating decimals are rational numbers. Okay? So we have to imply that this goes on forever and doesn't repeat. Okay, so this is just a visual look at rational and irrationals. Let's practice. We're just going to say whether these are rational or irrational. In fact, I want you to turn and talk to your partner. Get rational or irrational for all 5 of these. Ready, set, go. You have 30 seconds. Hey, that's better. Hey, that's a lot better. All right, it took us a long time. Yeah, you're not gonna be able to use it for the next 2 hours. All right, here we go. Bring it back in. So, square root of 64. Hands. Jory. Good. Why? This is a perfect square. Square root of a perfect square is 8, and 8 is a whole number. Awesome. All right, next one. Landon. Irrational, you say? Why? Well, there's got to be a reason, and it's on your list. What? It's a square root of a non-perfect square. This is not going to be 5 or 6. It's going to be like 5.4-ish. 5.4, et cetera, right? All right, next one. Hands. It's rational. Why? We're looking at this. There's no square root there. Okay, definition of rational. What is it? Anything that can be written as a fraction. So, why is that rational? Because it can be written as a fraction. It's a mixed number. You just make it improper and it's a fraction. Okay? Next one. Rational. Good, it's a repeating decimal, and we know that repeating decimals can be written as fractions. We know this one. What is it? 1/3, exactly, 1/3. Okay. I wonder if I can make this focus on the screen better. Whoa, yeah, that's way better. Way better, way better. It'll adjust, but still. I'm in shadow, but the screen you can see. Last one. Yep, Anna.
Irrational.
Why?
You can't write out a fraction that's like never ending.
So it's never ending, and it's
That would be.
not repeating. Good, so rational. We're going to plot those on a number line, and this is the last thing we're doing. Okay? So these are the numbers we're putting on the number line. You know if they're rational or irrational. We need to estimate this with our partner. Okay, so one thing that I would do is I would add some labels in here just to make it a little bit easier. I would add those labels in. Which one do you think is the easiest one to plot on the number line? Okay, so you say -3 and 2/3. Why? I can't hear you, man. You're 2 feet away from me. You can. Just because I can't hear you doesn't mean you're wrong. I just want to hear you. So you said 3 and 2/3 was going, or -3 and 2/3 was going to be the easiest to plot, and I asked why. Go ahead and answer that question. It's close to -4. Cool. I disagree with that, but you know, to each their own. If you think that's the easiest one, you plot that one first. Ashley? Square root of 64. Because the square root of 64 is 8, right? So just go to 8, and what should you write down at 8? Square root of 64. Boom. Now, I agree, Landon, with you that that one's the next easiest to plot because it's the only one that's negative, for one. So it's the only one that's down here, and you said it's close to 4. Close to -4. It's close. Is it closer to -4 or closer to -3?
Negative.
It's actually closer to -4. 2/3 is 0.6 repeating. So we need it to be closer to -4. Now the next one to plot. What do you want? I'm doing the square root of 30. Yeah, that's the next one I would do because I know it's not a decimal. I know it's not going to be right here. Right? These two are going to go in this little space. Square root of 30 is in between what? In between 5 and 6, exactly. And it's pretty darn close to the middle. It's 5 away from 25. It's 6 away from 36. So it's pretty darn close to the middle in between 5 and 6. Square root of 30. Now the next two, where are they going to be plotted? Yeah, this one's closer to 0. This one's closer to. So we want to make sure that when we plot it in that way. That 0.3 repeating is closer to 0, and 0.87231, etc. is closer to 1. So that's where I'm going to plot the 0.87231, and then the 0.3 repeating. Okay. All right, that's all. So remember, today's a no best schedule, so make sure that you're aware of that. Your homework is assignment number 28. I'll get that passed out to you. Yeah.
It's still preparing.
Yep.